Hi and welcome. Let's discuss the question of diameter of binary tree. Fine. So, given a binary tree, the largest path, the longest path you can say, not the largest but the longest path, fine, from one leaf node to another leaf node is the diameter. Longest path from one leaf node to another leaf node. Fine. Now depends on the question. The question may be asking you, telling you the longest path is in that path you need to count the number of nodes, or it may be asking that it is actually the number of edges. That depends. Okay, it will be mentioned. Fine. Now for example, if this is my binary tree, like this. So from this node to this node, this is my path, correct? So 1, 2, 3, 4, 5, 6, 7. 7 nodes. If nodes is there, and edges will be 7 minus 1, 6 edges. 2, 3, 4, 5, 6 edges. Fine. So we will just count the number of nodes in the path. Fine. If edges is asked in the question, we will return nodes minus 1 or simply node if node is asked. So is 7 the highest? I think in this example 7 is the diameter. There are other paths also you can consider. See, this is a one path with 1, 2, 3, 4, 5 nodes into it. This is another path with 1, 2, 3, 4, 5, 6 nodes into it. This is another path with again 6 nodes into it. Okay. So, and also you can see the path may or may not follow the root. Means the root is not necessarily in the path. For example, if we have something like this. Okay. Now in this example, this is my longest path from one leaf node to another leaf node without having a root into it. 1, 2, 3, 4, 5, 6, 7 is the answer. Fine. So that is what the question is asking. Let's see how we can solve it. Okay. So what we are going to do is see for each, what is a path means? If I want to know for a particular node, let's suppose I want to know for this node. Okay. For this node, how much deeper I can go. So on left hand side I can go 1 deep, and on the right hand side I can go 2 more deeper, correct? So that is the thing. But from this node to the below node, what is the height? What is the height of this node? That is what we need. From the left side also and from the right side also, correct? So if I just do like this. So now for this particular node, the maximum height is 3. If I just count the number of nodes into it, 1, 2, 3 on the left side, and from the right side the maximum height is 1. So left side 1 is the maximum one, so that is nothing but 3, correct? So for each node we can know that from the left side what is the maximum height, or from the right side what is the maximum height. This we can know. For each node, the left side can return its maximum height, and from the right side it may return its maximum height. For each node, for this also, for this also, for this also, for everyone. Now once we have the left side and the right side, now for a particular node we have actually two choices. Okay, so this may be the root or this may not be the root. Let's suppose this is not the root. Now it has two choices. Either the maximum path is the thing but goes through this, that this is the maximum path, fine, or the maximum path is max of left side or right side and plus 1 this is the maximum path. So either the maximum path is this itself, that this node, consider it as a root, or the maximum path is maximum of left side plus or right side plus 1 and return it. There are two choices here. So first of all, what it is doing is we are getting some left side maximum height and the right side maximum height. Fine. Once the left side maximum height is returned and the right side maximum height is returned, okay, then for each node we have two choices with us. What are these choices? Is, let's say we have answer 1. It is nothing but maximum of LR plus 1 of this node. So maximum of left side and right side, okay, plus 1 that is plus 1 of this node, is returned to its parent node. Fine. So there is one choice. Another choice is nothing but L plus R plus 1. That means this here is the path itself. There are two such choices, pretty simple to understand, that these two choices here. Fine. And our result is nothing but the maximum of answer 1 and answer 2. Correct? Maximum of these two. Result you can say is as a global variable. Fine. And in the previous we simply return answer 1. So for each node to its previous node we are going to return definitely this, the maximum height. Correct? Here also its children is returning the maximum height on the left side and the maximum height on the right side. So this node also should return the maximum height to this particular node from its side. That is what we are returning. But it also has a case that I can, from me also maximum path can go. So therefore this choice is there. Fine. And before this we get the left height and the right height. So left and right height is very simple. They are simple recursion calls. Okay. Recur for node of left, and recur for node of right. Okay. So we get the left height and the right maximum left height, maximum right height. Now we have two choices. First is either it can be maximum of left side plus right side plus 1, or it can be L plus R plus 1. Correct? That is, this particular node itself is the final root, that this example I am taking right now. Answer 1 is nothing but returning whatever the left side returns, the maximum height of the left side. Okay, and result is nothing but maximum of answer 1 and answer 2, and to its parent node we will return answer 1 definitely. Fine. So result is global. So for each case, for each node, result is storing the maximum possible case. For each node it is storing the maximum case, either this or this, either this or this, either this or this. For each node the maximum is stored. Okay. So finally we will get the maximum length, because we are already storing the maximum one. You just need to understand that these two choices are there, and this right here is used in many questions, this approach, that for a particular node we get by logic that okay, left side will return this and right side will return this. We call the recursion function to get the left side and the right side. Now once left side and right side returns, what are the choices for this particular node? Those choices we get, and according to the question we need minimum or maximum, we formulate it. Fine. This is not just in this question, this template is used in many questions for trees. Okay, just remember this, whatever this left side returns and right side returns, we hypothesize that they will return me the correct answer. And for this node, for a particular node, we have the choices, and accordingly the same thing happens again. Now for this part, this is my left side and this is my right side, correct? So we are returning the maximum, fine, from the left side and the right side, and storing the result in the process. So this is how we will get the diameter, the longest path from between two nodes. Now in case edges is asked, that is, it is said that in the question that the longest path is nothing but the edges, number of edges, then you have to print result -1. If it is said that nodes are there, in that case you need to print the result. Fine, because we are counting nodes here. This one is nothing but that particular node itself. So it is left side and it is right side. So left side, right side plus 1 is nothing but the node itself. We are counting the nodes here. Fine. So this is the implementation for diameter of a binary tree. Okay. So its time complexity is order of n and space is order of h because of recursion. Okay, because recursion stack is created, correct, of height h, the height of the tree. Fine. And each node left or right will be called once. So that's it. Do try to implement this out, fine, first, and then see the implementation. Let's look at the implementation. Tree is created and the root is provided to us, fine. Let's have answer as a global variable, or say, yeah, declare answer equals to 1, just if there are multiple cases. Now we can create a function okay, some recursion function, and pass the root into it. So if edges is asked, we return answer -1, and if it is said that the longest path you have to count nodes, then return just answer. Fine, let's recur it. Node star node. If node equal to null, in that case return 0. Fine. Else calculate the left hand side. Recur on node left. Int right equals to recur on node right. Fine. Now we can get answer 1 as max of left right plus 1, and we get answer 2 as max of either the answer 1 or left plus right plus 1. Fine, and result will be updated with max of result and answer 2. So what we did in answer 2, we did this step of finding the maximum, fine, between the answer 1 and this choice, that from this particular node the path will go, fine. And in the result, in the final answer, what we are doing is simply storing the maximum between answer 2 and the answer. That means this answer can be multiple answers for each and every node, so we are storing the maximum among all of them. We will return answer 1. That's it. This is the implementation. Okay, remember, if edges answer -1, if nodes only answer. Okay, so this is the implementation, guys, for this particular question. Thank you.